I want to begin by asking you if you know what is a plus b squared. A squared plus 2ab plus b squared, right? How about a plus b cubed? Does anyone remember this? A cubed, 3a squared b, 3ab squared plus b cubed. I mean, the way you can get this one from the first is you can multiply it like times a plus b, just like this, so that when you multiply b, this is a squared b right here. You multiply here, you get 2ab squared, b times b squared is b cubed. A times a squared, you write it over here. Just like when you do 3-digit times 2-digit multiplication, you can do that. Okay? B times 2ab is 2a, no, something's not right. Oh, okay. A times 2ab is 2a squared b. A times b squared is ab squared. Now you add them, and the nice thing about this is, if you write it this way, you can easily figure out which ones are the like terms. So you can just immediately say this is 1a squared b, 2a squared b, these are like terms, so this will add up to 3a squared b, a cubed, 3ab squared plus b cubed. Just like this. Okay? If you want a plus b to the 4th power, you would do that again. Just multiply this by a plus b. And we can go through the same process. However, a famous mathematician named Pascal realized that there's a pattern to these exponents. It's always 3, 2, 1, and no a, whereas there's no b, but 1, 2, 3. And that's going to happen for all the variables, all the terms. So he thought, why not just write down the numbers? So it's like, think of this as a 1. So 1 times 1 is 1, 3 times 1 is 3, 3 times 1 is 3. He was being lazy, but laziness pays off because sometimes it gives you creativity, right? So 1 times 1 is 1. And if you multiply a, it's a cubed times a, that's a to the 4th. So I should be writing a to the 4th, but I'm just going to write down the coefficients. It's like 1 times 3 is 3, 1 times 3 is 3, 1 times 1 is 1, and then you add them up, and you get the coefficients 1, 4, 6, 4, 1, just like this, right? And then because we know how these things form a pattern, we know, I can just look at this and say, hey, a plus b to the 4th power is a to the 4th, 4 decreases 1, and then increases 1, 6a squared b squared plus 4ab cubed plus b fourth, just like this. And then he developed this idea further and came up with a triangle with his own name. Yeah. So Pascal is known for other things, like he made calculators, mechanical calculators, stuff like that. He was also a theologian. But I think among all of his works, the most famous one is what we call the Pascal's triangle. See, it should be 1, 1, 1, 2, 1. Remember, this is 1, 2, 1 is a plus b squared, 1, 2, 1, right? And then you write 1, 3, 3, 1, because you have 1, 3, 3, 1. And the next one is 1, 4, 6, 4, 1. And if you think about how we got these numbers, I mean, I erased it, but if you recall, it was like 1, 3, 3, 1 was written once, and then it was shifted one to the left, and you added them, right? So that amounts to actually just adding neighboring numbers. Right? So in this triangle, 1 plus 2 gives you 3. Right? 1 plus 3 gives you 4, whereas 3 plus 3 gives you 6. 3 plus 1 gives you 4. Right? And this beautiful object is called Pascal's triangle. And the next one is you have 1, 5, 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, and 1. And you can continue. Of course, you know what this means. It means that a plus b to the 5th power is 1, 5, 10, 10, 5, 1 with the appropriate powers of a and b. Okay. Now, why are we doing this? Well, I want to teach you the power rule. And to do the power rule, I want you to recognize that there's this 1, 2, 3, 4, 5 that appears right after the highest term, highest order term, right? Same thing over here. Just before the constant term, there's this h. Just before the constant term, there's these 1, 2, 3, 4, 5. It just goes forever. Okay? So, knowing that, let's try to find out the derivative of x to the 5th. So now we're back to calculus. That was just for fun, okay? With just a little bit of usage for this discussion. Okay? So x to the 5th power prime, according to our definition of the derivative, is you have to send h to 0, and you need x plus h to the 5th power minus x to the 5th power divided by h. Now this is like a plus b to the 5th power, so we can use that, right? So we can use that and say, hey, that's x to the 5th power plus 5x to the 4th h plus 10x to the 3rd h squared, and I'm getting tired, so I'll just like this. Okay? Again, if you're lazy, sometimes you're forced to be smarter. So being able to ignore this actually makes you understand more. Okay? So minus x to the 5th power divided by h, and we're sending limit h going to 0. Okay. Now what's canceling? What cancels? These two cancel, right? And then if you divide, you see that this is h going to 0 of 5x to the 4th. Well, because you're dividing by h. If you divide h by h, it's this. H squared divided by h is 10x to the cubed h. Goes da da da. And because I was too lazy to write these down, you have to use your imagination to think about what's going to happen here. Okay? What's the power of h here? Right, the very next term has h to what power? 4th power, no, 3rd power, and then 4th power, and the 5th power. So I just didn't bother to write 3 more terms there. There are 3 more terms that I didn't bother to write.
Like, wouldn't it be x to the 3rd and x to the 2nd?
Yeah, x squared, h cubed,
Oh.
and then x times h to the 4th, and there is no x, there's h to the 5th.
I just remembered the x.
Yeah, yeah. And then h will cancel, h cubed will cancel with this h, leaving you with h squared on the next one, right? the next one will be h cubed, and then h to the fourth. Those will be the terms in here that I didn't bother to write. Get it? You want me to write everything? No, we don't have to, right? I mean, we just took an exam. Why not just be carefree for a while, right? Okay, h equal to 0, so you get 5x to the fourth as the answer. Now, I think 5 is a big enough number that you can actually see what's going to happen if you write this for x to the nth power, right? So what would happen if you do x to the nth power prime? Then you would be doing limit h going to 0 of x plus h to the nth power minus x to the nth over h. And if you expand this using the Pascal's triangle, you'll definitely have x to the n as the very first one. The very next one will have n times, because of this property, whatever this number is, that number appears. See, if you do fifth power, 5 appears here, right? If it was fourth, there would be 4 here. So same thing happens here. If it's nth power, n will appear here, and there will be 1 less, but h will be attached. And then there will be more terms where there are more h's. Okay? Minus x to the n, which will cancel the x to the n, right? Over h, limit h going to 0. So that when you divide by h, the only thing that survives is x to n times x to the n minus 1 plus some other terms with h's in there, right? But you're going to send h to 0. So if you set h equal to 0, what's the remaining thing? N times x to the n minus 1. That's what you're going to get, right? And that's the first important fact I want to teach you today, that this thing called the power rule, which says if you have x to the n, you differentiate, the answer will be n times x to the n minus 1. To understand that, you need some imagination, and I think young men like you, men and women like you have the imagination, right? You don't? If you don't have imagination, that's, I feel so sad for the next generation.